So guys, now we are ready for the complete paper analysis for GATE 25 Data Science and Artificial Intelligence. So today is 15th Feb and exam just now completed, and we have received so many memory based questions from our student side. So first of all, how many pattern of questions has been asked? As you all know, 65 questions are fixed. So MCQ were 35, NAT 12 and MSQ 18. So these are the pattern of questions that has been asked in today's GATE 25 DA paper, guys. Okay. So I would like to invite our computer science expert mentor. So please come, Davi sir.
Hello, sir.
So how was the paper difficulty level?
Sir, just we spoken with the students,
Yes, yes.
our students only, our CSA student, DA students, they written the paper. So they were telling easy to moderate, and those who prepared well in mathematics, they might have performed well. But surprisingly, this time mathematics they given 43 questions, 43 marks.
Oh,
Only in engineering mathematics, 43
last time
marks.
35 around.
35, 34, 35 questions marks were there, but this time 43 they increased.
It means engineering mathematics itself weightage is
43
43
plus general aptitude 15 marks.
15, so around it is 58.
58.
So and so my question to you, suppose that one student prepare for CS branch. Okay, we have DBMS common, we have sir programming part common. So according to that, if the student who only prepare for computer science, how much they have a scope to score here in this DA paper?
Sir, just we can have an analysis also. We have some data. So little we can go back. We can go back here.
This is 24 data.
24 data,
MSQ was 37.
37, 12 and MSQ questions are 16 were
This
there.
time 18 this is.
Is this time 18. So exactly when it comes to here, general aptitude anyway 15 marks. So probabilities, linear algebra, calculus, these three topics if you see.
Combine these three, na, then it is
So
itself has 8 and 16 plus 14, so
36.
30.
36 marks.
36.
36 last year.
But
That's only this mathematics, only mathematics, sir.
only mathematics, na.
Only mathematics.
But it's 8 and 16. 16 plus 14 is 30 only, na.
30, okay, 30 question, 30 marks from
But I think there is error. But
error
I
sum.
know the 34.
34 marks were there, like. So the only this mathematics only now. So now algorithms, this is common, data structure is common. Little Python program questions came, that is students, our students able to solve, CSA students. And DBMS 13 marks came. So around some more than 60 marks can framed it, can able to attempt it. Now similar way, when it comes to 25 paper, so 25 paper we can see here,
Here is 24 and 20.
comparison. So they increased MSQ questions 18 now,
MCQ earlier 37.
37 now 35,
MSQ
12 was there,
and
so
here is
18 increased,
and here is numerical entry 16.
reduced like. So this time MSQ question again played more questions. Now coming into the structure, this we have seen. Now here is a point, mathematics.
This is very important.
Mathematics you can see, 43 percentage.
So guys, it is a very, very important information that every aspirant should note down. Even if you have other branch other than CS, if you are writing the DA as a second paper, then there is a huge scope that you can definitely make a good rank. So it's all about, guys, ki as of nowadays, as we can see that ki how much popular this artificial intelligence AI. So other branch students also can think about in the upcoming year GATE 26, because if you may write this exam na, then engineering mathematics and general aptitude itself, even here aptitude is 16. Generally 15 only, and it's 15 only. So 15 and 43, guys, around 58 marks. 58 marks, and out of this DBMS and all. So you all know that ki around last year also, I think around 32 or 30 cutoff, na, DA cutoff.
37 was there.
37 was cut off. Okay.
Even we can expect last year also easy to moderate was their paper. So this year also our student, CSC student written, they are also saying same things, sir, easy to moderate. Those who specially prepared for DA paper, they might have scored even more marks. And machine learning and artificial intelligence, last time also around 17 marks came. So this time also 17 marks prepared here. So that is, if you know you can perform. So if I ignore that 17 marks, still more than 80 marks we have.
And out of, suppose that someone target 80 marks only.
80 marks only.
Then out of 80, can I secure 60 marks?
Easily, sir.
And
Easily.
60 marks, it is itself a big achievement.
Yes.
Because if you have a 60, if you have a 60 marks in DA branch out of 100, still you have a scope to make under 200 rank, 200 to 300 rank, and you can easily get the IITs or IISc or even some PSUs also if they recruit through the this DA papers.
Some only there, but most of the IITs like last year they increased admission for this data science. This year also even we can expect more institutions they can offer for the DA artificial intelligence with the combination. So I hope like the CAC even other branches like the data structure algorithms also not that much tough even compared to last year. This year also average they maintain. And upcoming GATE aspirants also like you can choose this paper as a second paper like especially mechanical student, electrical and EC students also they can take this as a paper because EC and mechanical and students they have mathematics part is more. So this advantage now. So 43 is like a very good number, na sir? Like it's a very good number.
Very good number. And again, general aptitude is there. So 58 marks out of 50 marks. If you are managed to secure even 40 marks, and even for the computer science students, if you can easily manage to score in DBMS 13 out of 13 in where is DBMS 9 marks out of marks maybe 7.
15% they given here.
Programming structure algorithm. So easily you can manage 60 plus marks. Okay, maths and aptitude you need to score 40 plus, and remaining all the other subjects. Even if I will not count artificial and machine learning, still you have a scope to secure 60 plus marks easily if you prepared well for the computer science.
Computer science.
Definitely.
So, like yesterday night only some student like the sir should I write the paper or not? I did not prepared it. I said blindly I said just go and sit and write it like whatever your CSE knowledge you just apply more than 60 possible. The last year our students scored 65 70 marks our students scored. So this time hopefully our students also going to be get good marks in a DA paper. Sir, coming into the point like like segregation we did like for a 1 mark 2 mark. So engineering mathematics you can see 28 questions total.
Oh, very nice.
So 15 questions of 2 marks and 13 questions of.
So around 43 marks.
Sir, we segregated some data. We have linear algebra only 6 questions given.
Oh, very nice.
6 questions of 2 marks.
To 12 marks.
12 marks only linear algebra. CSE we expect 4 marks only. Data the DA paper 12 marks of 2 marks like I think 4 or 5 1 mark question they given from that topic only.
It is a data science and DA branch, but you can say that it is including mathematics branch also.
Mathematics, more into mathematics only. More mathematics only like.
Because around more than 50% weightage is just mathematics and aptitude.
Aptitude only. So aptitude also easy like even if just practicing PYQs of the general aptitude you can make sure
other
to
branches.
other branches you can able to do it like. So
So
like
do we have Rohit sir having some questions?
So some questions are there.
So guys, we will start with some questions. Okay, some memory based questions we have. So I would like to invite our Rohit sir. He will come and he will solve some questions. Whatever questions we have received till now, we will provide you the detailed solution. Just like in the last weekend, we have did the complete paper analysis for the computer science forenoon session, afternoon session, electrical, instrumentation. So all the paper analysis we have did on the same day of the exam, and we have provided you the memory based solutions as well as the expected cutoff. Similarly guys, for today's session also, today evening also we have electronics and communication. So we will be live today at 6:30 p.m. and we will discuss the complete exam analysis for the GATE electronics and communication paper. We will discuss all the memory based questions here only in the live manner. So now I would like to invite Rohit sir. So he has some questions. He will provide you the solution. Followed by after that Priyanka ma'am will come and she will solve some engineering mathematics questions. Yes. So Rohit sir, ready? Okay. Chali. So whatever question you have received till now, by observing that, what is what you can say that on the difficulty level?
Difficulty level is sir easy to moderate only. Okay. Questions are like moderate from this programming parts and
So
DBMS
till now,
also.
how many questions you collected?
Around 6 questions I got here.
So
Yeah.
so just start the solution.
Yes,
please.
sir.
Okay.
Okay, so let's start the discussion. See, anyhow, this on 13th, I took one session in the evening regarding this PYQs of the previous year, and in that session we have already discussed some concept like insertion, bubble soft, and on that concepts already questions came. Okay, so let's start with that questions here. Okay, so the first, let's take the first questions here. The first questions was from, okay, the questions, okay, the question says here, see, this is the MSQ questions. MSQ questions. Question is, suppose that insertion sort. Suppose that insertion sort is applied to the array, and here the array is given. Okay, the here array is given here. The array is given with the data 1 3 5 7 1 3 5 7 9 11 x, then we have 15 and 13. This is the content of array. Okay, these are nothing but the content of array here. Now it says here exactly, and this array takes exactly 2 swaps. It takes exactly 2 swaps to sort the array. Fine. Then question was, select all possible values of x. Okay, and the options here given as, options A was given this 14, B was given as 16, C as a 12, and D option was a 10. Fine. This question is MSQ question. Fine. So see, again we have already discussed in the session that this insertion sort, how this insertion sort works here. Basically it divides the array, okay, into 2 parts. One is the already sorted. Okay. Yeah, we'll discuss, yeah, that same functions. The answer for that function of 15, 10 is nothing but 160. 160 is the answer, that recursion. Fine. So first let's see here. So again we have already seen this insertion sort, how this works here. Basically this divides the array into 2 parts. One is the already sorted array and one will be the set of keys. Now from the set of keys we'll start, okay, we'll take one of the values and we'll insert into the sorted array. Fine. So let's see here how this works here. I'm just giving you a small information. This insertion sort, we have already discussed insertion sort. Basically we are having this complete sets here divided into 2 parts here. This is nothing but already sorted array. Fine. And here we are having the set of keys. Now here from this set of keys we'll take one of the keys and we'll insert into the already sorted arrays. Okay, we'll try to find the correct position for that key, selected keys, and we'll insert at that positions through the swapping here. Fine. Now see here, if you observe this content here, it is a 1, 3, 5, 7, 9, 11, and then here we have x here. Now here they are asking here, what should be the value of x such that it will take, okay, it will take here only 2 swaps to sort the complete array. It takes exactly 2 swaps to sort the array. Fine, getting my point now. So I can see here, we'll see, before this x, this complete is already sorted. Okay, so what we'll do here? So we'll take here, let's take the first option, option A. Option A is nothing but 14. So here we'll take this x equal to 14, and for this x, see here, for this x here, okay, the complete part is already sorted. Now here see, the already sorted part is nothing but this only. Here we are having this 1, then we have 3, then we have 5, then 7, and the 9 and the 11. Getting my point? Understood? And here the set of keys here, the set of keys are here x, okay, this is our x, here is 15, and here is our 13. Getting my point? Now here this time, okay, I took this x equal to 14. If I took this x equal to 14, okay, now let's pick this 14 as a key. Now we'll try to find the correct positions, okay, and we'll try to insert the 14 into the, okay, already sorted array here. Now if you insert this array here, see, in this next step here, okay, or we can say here pass 1. Okay. Okay, after this the past one will be nothing but here. We'll try to insert the 14 here. Now 14 gets compared with the 11. Because this 14 is more than the 11, then there is no swaps. There will be no swaps. Getting my point? Understood now? There will be no swaps here. So again, after this past one, the array will look like here, see. The array will look like here. I'm writing the content only. It is nothing but 1, then 3, then 5, then 7, then 9, then 11. And this 14 is inserted here. Because of this insertion, there is no swaps here. Fine. Now the rest set of keys here is nothing but here 15 and 13. 15, okay, 15 and 13. Okay, so because of this, if I take the x equal to 14, there is no swaps here. Fine. We are having swaps equal to 0. So for the pass one, we have swap 0 swaps. Swap is equal to 0. Now we'll go for the pass. We'll go for the pass 2. Pass 2. So if I go for the pass 2 means we'll take one more keys here. One more keys means here 15, and we'll try to insert into the already sorted array. Now if I take the 15 here, now it gets compared with the last element of the already sorted array. Now the last element is 14. Now if I compare the 14 with 15, then 15 is more than the 14. It means there will be no swap. Simply the 15 will be inserted to the last here. Understood? So after pass 2, see here, after pass 2, the array will look like here 1, 3, 5, 7, 9, 11 and 14, and last one is 15 here. Understood? Again for pass 2 also, we have the 0 swap. Swap equal to 0. Now see in the set of keys here where we are having only 13. Okay, only left is 13. Now for pass 3, what we'll do here? For pass 3, we'll take the 13 and we'll try to insert into the already sorted array. See here. What we'll do here? So we'll take the 13 and we'll try to insert into the already sorted array. Then see here. Now when this 13 getting compared with the 15, then again see, because this 15 is greater than the 13, then again here I need one swap. One swap means here the resulted array will be look like here. After this one swap, it will be nothing but 1, 3, 5, 7, 9, 11. Then it is having 13 and 15. Then again this 13, here we have 14. One more is 14 only. Okay. So it will be having 14. Okay. So after 11, we have 14. Then we have 13, and last one is here is 15. Now see, again there is one swapped because of this 13 and 15. Then again this 13 is getting compared with the 14 here. Then because of this, again I need one more swaps. So finally, after these swaps, the array will look like here. This is a 1, then 3, 5, 7, 9, 11. Then here is 13, then 14, and the last one is 15. So now if you observe, now after these two swaps, the array is already sorted. Now here, understood? It means to get the sorted array in pass, okay, in pass 3, this is our, I can say this is pass 3. Pass 3. So pass 3 needs 2 swaps here. This is nothing but we are having the 2 swap. Swap equal to 2. Okay. So if I keep the x equal to 14, then it is taking again 2 swaps here. And asking here, the question is exactly same. It takes exactly 2 swap to sort the array. For that, find the value of x. So if I keep x equal to 14, it will take exactly 2 swaps to sort the array. It means nothing but here, option A is correct. Option A is correct. Getting my point now? Understood? Now we can go little shortly. See here, see. Now concept is clear now. Now see here. Because this is the MSQ, we will try for the option B also. Now if I keep the x equal to 16, if I keep x equal to 16, now see what will happen here. What will happen, see here. If I keep this x equal to 16, then when 16 getting compared with the 11, like here, 16 getting compared with the 11, then there is no swaps. Then again, when this 15 getting here, when this 15 getting compared with the 16, then there will be a 1 swap. And because of 13, again 2 swaps. Means if I keep here x equal to 16, then to sort the complete array, it will take here 3 swaps here. It will take 3 swaps. Swaps equal to 3. 1 swap will be required for the 16 and 15, and 2 swaps will be required for the 13 here. Again 13. Same. Everything is same. Understood? So it means here option B is incorrect. Okay, option B is incorrect. Fine. Now see again, let's take x equal to 12. If I take x equal to 12, how many swaps required? See here. Again, if I take x equal to 12, then there is no swaps with 11 and 12. 0 swaps. Again with 15, again it will take 0 swaps. Getting my point? Again with 15, it will take 0 swaps here. Now with 13, it will take only one swap. Why? Because here this 13 is, okay, only less than the 15. So again 15 and 13 getting swapped, and after this array will be complete sorted. Means here it will take only one swap. Why? Because as soon as this 13 and 15 getting compared, it will swap and array will be already sorted. Why? Because x is equal to here 12. Okay, so again with the x equal to 12, it will take only, okay, it will take only one swap. Swap equal to 1. Means again I can say C is also not right answer. Why? It says here exactly 2 swaps must be there. Okay, fine. Now if I take here x equal to 10, see here. Now if I take this x equal to 10, what will happen here? See, then if I compare this x equal to 10 with the 11, then here I need 1 swaps. Getting my point? 10 with the 11 is 1 swaps. Then 15 is getting compared with the 11, then there is no swaps. Then again because of this 13, I can say 13 is getting compared with the 15, will be having 1 swap. So because of the 10, 1 swap will be nothing but with the 11 and 10, and 1 swap will be nothing but with 13 and 15. So again 2 swaps will be required. So if I take x equal to 10, again here I need 2 swaps. Swap equal to 2. 1 swap, see I am writing here, the first swap will be between our 10 and 11. Okay, here 11 and 10, here required the first swap, and second swap will be nothing between the 13 and 15 here. Okay, here 13 and 15, or I can write here is 15 and 13. 15 and 13. So these 2 swaps will be required if I keep the x equal to 10. Okay, so again to sort the array, to get the sorted array, again I need 2 swaps if I keep the x equal to 10 here. It means this D is also right. So here the answer is nothing but options A and D, both are correct options. Understood? Any doubt? Fine. Now let's take here one more questions. Okay, one more questions based on the function. Okay, that recursion only. Let's take the recursion questions. See here. Okay, here the functions was declared. Okay, this is a recursion question from the programming. Recursion from the programming. Here one functions were declared here. Function f taking 2 parameters. Python is given here. Okay, functions a comma b here. Functions take 2 parameters a comma b here. Now a statement was if a is equal to 0, then simply return b. Okay. Now the next statement is if a modulo 2 is equal to 1. We know this modulo is used to check whether the number is even or odd. If the number is odd, then the condition will be true, and if the number is even, the condition will be false. So if for all the a value that is our odd, then the condition will be true, and in that case if it is true, then it says return, it says 2 into, okay, 2 into function a minus 1, and there is a operator in the Python that is called the floor division by 2, and comma it's b. Getting my point? So this is nothing but the parameter, means here we are going to update the parameter and we'll call the f functions again here. Fine. And here the last one is nothing but here one more return function is there. If this is not, okay, if the condition is false, if the number a number is, okay, if it is even, then again here go and return this here. Return, it says here b plus function of a minus 1 comma b, like that. Understood? And asking here print okay, inside the printf we are passing 15 comma 10. So asking what should be the, means asking the above program will print what. So just find the output here, Getting my point? Understood? So let's see here. Let's say this is the recursion, very simple recursion here. Understood? Now see if I call here, see the functions calling will start from the, okay, this printf function. See again, whatever the value this function call will return, that value getting printed by this printf function. Okay, print function. Now see here, so we are calling this function f here, and the functions we are passing the parameter value is 15 and 10. 15 and this 10. Now here if I pass this 15 and 10 to the functions, then see here, see the receiver parameter here is a and b. So inside a this 15 will be stored, okay, inside b the 10 will be stored. Fine. Now see a having 15 and b having 10. Now the condition will be checked here. Is, see, if a is equal to 0, is true or false? Because this a is not 0, the condition is, okay, yeah, Absolutely, the answer is 160 only. Fine. So A is not 0. If A is not 0, then again this return will be not executed. Then the next here is if A modulo 2 is equal to 1. So this is true or false. Why? Because this A is odd only. So if this A is odd, then condition will be true. Then if it is true, then simply return this. Okay. Now here see condition is true, then I am returning here, or let me write it here. Here, if okay, here if A is nothing but 15 modulo 2 is equal to 1, the condition is true. Why? Because this A is our odd, so this condition is true. If it is true, then simply return. What we are returning here? We are returning 2 into function. See here, functions of, it says here A minus 1. What is our 15? So A is nothing but 15. 15 minus 1 is 14. So 14 floor division of 2 nothing but it is just 7 only. So we'll call the 7 comma B. 7 comma B. What is B? B is 10 only. So we'll call these functions. Getting my point? Understood? Now again see here, if I call this function, then again tell me here, what is this A value? What is this for this function call? What is A value? So here this A is equal to 7 and B equal to 10. Getting my point? Again see, whenever I'm calling these functions, again what will happen? This A is okay 7 and B is 10. Now again the condition will be checked. Condition is true or false? This condition is false. Why? Because A is not 0. Then again if it is false, then skip this part here, return B. Now directly go here, A modulo 2 is equal to 1. True or false? It's true only. Why? Because see here, if, what is A? A is 7, modulo 2 is equal to 1. This is true. Why? Because this A is odd only. So this part is true. If it is true, then again return this part. What we are returning here? See, we are returning here, return 2 into function of, see here, function of A minus 1 by 2 floor. Okay, so 7 minus 1 is 6. 6 floor division 2 is nothing but only 3 only. So here again it value is 3 and what is B? B value is 10, so it will pass the value 10. Getting my point? Now again I am writing, see, I am calling these functions here only to save the space here. See, so I am calling the functions f of 3 comma 10. F of 3 comma 10. What is A value? A value is 3, B value is 10. Getting my point? Again see, again I am calling the function f with A equal to 3, B equal to 10. Again it will start from the starting here. So what is this condition? Condition says if A is equal to 0, tell me, is it true or false? It's false. Why? Because A is not 0. If A is not 0, then simply skip this part. Okay, skip the return B here. Then directly go here, execute if condition here. If A means 3 modulo 2 is equal to 1. This is true or false? This is true only. Why? Because this 3 is odd. So if A is odd, then condition will be true. Always remainder will be 1 only. Getting my point? Because this operator always gives the remainder here. Okay, so the condition is true. If it is true, okay, if it is true, then simply again call the return. Okay, or return the value 2 into function of, what are the functions? A minus 1. A minus 1 means 3 minus 1 is 2. 2 floor division 2 is 1 only. So here we'll call 1 comma B. B is 10 only. Understood? Again we'll call this function with A equal to 1 and B equal to 10. Again see, again if I am calling these functions, again what will happen? It will check condition is false. Why? Because A is not 0. So I skip this return B part. Again go and execute this. Again what is this condition here? If A, what is A? A is 1. 1 modulo 2 is equal to 1. True or false? It's true. Why? Because this 1 is nothing but odd only. So it will be true only. If condition is true, again return. What we are returning here? Return 2 into function of, again see, now see again 2 into function of A minus 1. What is A? A is 1. 1 minus 1 is 0. So 0 floor division. See, it's nothing but here 0 floor division 2. So it will give us the whole number 0 here. Understood? So result will be 0 only. So here it will pass the 0 comma 10. Getting my point? Now here see, if I am calling the function f with 0 comma 10, now here the A value is 0 and this B takes 10 only. Now if I call the last functions A equal to 0, B equal to 10, then what will happen? Here the receiver A is nothing but here it's 0 and B is 10 only. B is 10 only. Then what will happen here? Because the first condition is true. Why? Because it says that if A is equal to 0. So here A is 0, then it says return 10. Then the value of this function call here, f of 0 comma 10, nothing but here it is 10 only. Why? It is returning the value B here. Okay. So it means here the value of this function, see here, the value of this function call is nothing but it's 10 only, 10. Now see here. Now see, this function is called inside f of 1 comma 10, f of 1 comma 10, and the value of f of 1 comma 10 is nothing but it's depend from the return function. So return is nothing but return 2 into f of 0 comma 10. So value of f of 0 comma 10 is nothing but 10 only. So 2 into 10 is nothing but 20. Getting my point here? This complete value is nothing but 20. This is 20 only. So now it says return 20. So where will return here? It will return the calling function. Calling function is nothing but here f of 1 comma 10. So value of this nothing but here is 20. Understood? Again see, again same thing here. So from where we call this function? We call this function inside the function called 3 comma 10. So what is the value here? The value of 3 comma 10 depends on the return function here. Getting my point? So we are returning here 2 into 20. So 2 into 20, this complete value nothing but here 40. So value of this means here inside this function call we are returning this 40 here. It means the value of this function is 40. Understood? So here we got function here. See, function of 3 comma 10 is 40 only. 40. Now from where we call here this function 3 comma 10 here we call this function from function of 7 comma 10. Now the function value, this function value depends on the return functions 2 into 40. So 2 into 40 is nothing but, this value is nothing but here 80. So value is nothing but here function of 7 comma 10 is nothing but 80 only. This value is 80 only. Again, we call this function from the original function. So value of this functions depends on the return function here. 2 into 80. So 2 into 80 is nothing but here is 160. Now this 160 return to the functions here. So value of these functions f of 15 comma 10 nothing but here is 160. Now this 160 will be returned to the print function here. The value of these functions is 160. It means this print functions will print the value 160. So output is 160. Okay. So answer is 160. Understood? Very good. Now let's take one more questions from the Python only here. Python. See here the questions is here programming questions. It says here it says here this question is MCQ questions. It says here consider the following Python. Consider the following Python declarations of two list. Of two list. Here the lists are given. The A list is given here. The A list is given. The list A is given. A is given as 1, 2, 3. Here the values are 1, 2 and 3. Fine. And the list B is given with a value 4, 5, 6. 4, 5, 6. Understood? Now it says here, see, which of the following statement will result in the result should be A equal to, the list must be value having values are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. And here the options A is given here. A dot append B. Then it says here option B is nothing but A dot update B. And here option C is nothing but A dot insert B. And the D option is nothing but A dot extend B. Getting my point? Fine. Now see here, asking here which of the following statement here, programming statement, Python statement will result this statement, result the A equal to 1, 2, 3, 4, 5, 6. Getting my point? Now see, update is not the answer. Why? Because this update method is used to update some value inside the list here. So B is directly incorrect here. Now see here, now see this insert, this insert method is used to insert, this method is used to insert, at particular index in the list. Understood? Because of this I can say here, see, here we are adding this 4, 5, 6 at the end of this A list here. So we are not inserting any element in the particular index. Fine. So it means this option C is also incorrect. Now what is C? What is this A option? A option says here A dot append B here, append B. Now see, this append method is used, this append method is used to insert to insert, okay, one value, okay. This append method is used to insert one value at the end of the list. At the end of the list means here one value, whatever the value will provide, that value will be added at the end of the list A here. Means this append will increase the size of list by 1. Okay, it will increase the list of size by 1 here. Fine, getting my point? Because of this here I can say, see here, now we are having this A list having 1, 2, 3, and again we are adding this 4, 5, 6 at the end of this list A. Okay, we are not adding one value at the end here, we are adding 3 value here, understood? So because of this here, the option A is also incorrect. So what is this extend method here? Last option is extend method. See here, now this extend method, okay, this extend method here, this extend method is, this is, okay, used to extend the size of list. See here, this extend method is used to extend the size of list by the, okay, by the number of element or value, okay, we pass to the method here. Now see here, now we are passing this B here, B list. Now see, so B list is having how many elements here? B list is having 4, 5, 6, it is 3 elements, fine, or we can say 3 value we are having in the list B. Now see, this extend method is used to extend or increase the size of list by the number of element we are passing to the method. So we are passing 3 elements. So what will do? It will increase the size of list A by 3 and it will append all the list B into the end of this list A. Understood? So basically this extend will be used to add 4, 5, 6 at the end of this A. So this option D is the right answer. Understood? So this is the right answer. Fine? Very good. Okay. Now again let's take one questions from the data structure. Okay, this question is from the data structure and this is our MSQ questions. MSQ question. Question says here, see, question says here, which of the following input does binary search takes, okay, binary search takes, okay, order of log n time. Means the question is simple, asking here for which type of input the binary search will take order of log n time to search any elements into the list. Understood? And the options are given here. The option A here, the option A is given here, an array of integers, okay, in increasing order. Okay, now the option B is given here, same here, an array of an integer in any order. Now option C is given here, okay, this time they are given here an linked list and linked list of an integers, okay, in increasing order. Getting my point? Now options D here, the option D is given here, okay, and linked list of an integers in any order. Fine, these are the given options for the questions. Fine. Now if you observe carefully, the one thing is very important here, that binary search. See here, again in the classroom we have discussed this binary search, okay, binary search. So in this topic we have already discussed, for the binary search our input input here, we have discussed here, whenever you're discussing this binary search topic, we have already discussed, the input must be here, the input must be sorted array. Sorted array means technically see, this binary search is implemented on the array itself. We will discuss why this is, but see here, the only requirement is the input must be in the sorted array, then only the binary search will work. Okay, so basically the binary search input must be sorted or increasing. Okay, it means here whatever the options we are given with the any order, these all options are incorrect. The first thing is clear here, the option B and option D incorrect here. Why? Because inputs are given in any order. Getting my point? Now options are, now here the right options could be options A or C, could be options A and C. Fine. Now see here, let's discuss about, now let's talk about the options here. Option A says here an array of n integers in an increasing order. Now if I take here one small example, see here, now let's take here array of some elements here, 1 2 3 4 5 6 7 here elements, I can say here 1 2 3 4 5 6 7 and 8. Now if I want to search the element, let's assume here our search key is 3. Our search key is 3 only. Now if I want to search key 3 into the sorted array here, then simple procedure is here. The first method is nothing but here, the first step is find the mid here. We have already discussed. Again see, same concepts we have discussed in the same. On the 13th we took one session on the PYQs. That's why I says here PYQ is very important. Okay, so definitely they won't ask the same questions, but they can ask the same concept here. Okay, so again see, binary search, it means here nothing but the first step is division means find the mid here, find the mid. So how to find the mid? The same is nothing but low plus high by 2, and it is a floor. Understood? It means take the low and high. What is low? Low means the lower index, high means the higher index. So let's assume the index is nothing but starting with 0 here. So 0, 1, 2, 3, 4, 5, 6 and 7. So what is 7 plus 0? It is 7. 7 by 2 is nothing but 3.5. So floor means nothing but here 3. So again the mid is nothing but 3 here. So go to the 3 and compare with the search key. Is it equal to 3? No. Now here the second, this is the first step. The second step is comparison of search key with the mid element, Understood? This is the second step. So after comparison, if you find the key here, if it is matching, then simply pass or return the index here. But if it is not matching, then we'll say if the search key is less than the mid element, then definitely your search key will be the left side, or either if your search key is more than the mid element or greater than the mid element, then your search key must lie on the right side, of the mid element. Okay, so again this see the binary search divides the array. Okay, at every step the binary search divides the array into 2 parts. Okay, one will be left, one will be right, but at a time it will solve only one part, either the left or the right, depending upon the comparisons of the search key with the mid element. Understood? Now here, because the search key lie towards the left side, so again we'll perform the binary search on the left half. Okay, on the left half, and this will be continued. And we know the binary search here, the recurrence relation for the binary search is nothing but here. It is nothing but here. Okay, t n by 2 and some constant. Again in the classroom we have already solved the time complexity for this nothing but order of log n. So it's take the log n time here. So it means option A is correct. Option A is correct. Now let's take the option C here. Option C. And in the classroom also we have discussed about the option C here. Okay, let's take the option C here. It says we have n. Okay, we have n integer linked list here in the increasing order. So let's take the one small linked list here. Let's take here this linked list here, and because the linked list is nothing given, see, it is not given whether the linked list is a single linked list or double linked list. So I am taking the standard one, that is our single linked list. Fine. So here it is just single linked list. Okay. Fine. These are the given linked list nodes here. Let's take some small example. This is the linked list here. Fine. Now see how this linked list connected here. So this nodes connect to the next node here, next node here, next node, and last will be here. It will be null here. Fine. Elements are in the increasing order, so elements will be 1, 2, 3, 4, 5, 6, and 7. Same 7 elements here. Fine. Done now. Now see again. The thing is, the binary search input must be sorted. So here the given linked list is here. The given linked list nothing but here in the sorted order. It is in the sorted order. No problem here. But the problem is here. See, the linked list, the binary search works on finding the mid. Okay, like here in the array, the first step is find the mid. So how we are finding the mid? Low plus high by 2. Okay, it will take some constant time. Okay, if it is nothing but an array only. Okay, just low index plus high index by 2, it will take some constant time. But the problem with here, the problem with the linked list nothing but here, the linked list here nodes can be at any address. Okay, because this is nothing but here the sequential access here. Understood? Node can present in the any places in the memory here. So again, if I want to search any node here, then the only one option is through the next pointer here. Through the next pointer I can go and I can access here, like maybe this node is at 1000 here, it may be of 2000 here, it is of 3000 here, 4000. This is on the 5000, here is 6000, and here is a 7000. Okay, so if you want to search anything, or if you want to find any key into the linked list here, the only option is through the next pointer here. Understood? So the problem with the linked list is nothing but here, if you want to find the mid here, then to find the mid here, you need to traverse the complete array. Okay, you can use the two pointer concept here. Okay, one pointer will be here. Okay, both will be on the same. This is a pointer P and this is a pointer N. Okay, you can take the 2 pointer here, 1 pointer here, maybe this N will update through, and next means at a time this N will jump 2 nodes and this P will jump through. Okay, this P will go through here. Okay, P next means it will jump through 1 nodes here. Again, we have seen in the classroom that if one pointer is jumping through two nodes here, and if one is jumping through 1 nodes, then definitely when this N pointer will reach the last node, then this P will be somewhere in the mid here, Getting my point? It means to find the mid of this linked list, it will take order of n by 2 times, and this is equivalent to order of n. Getting my point? So to find the mid in the linked list, it will take order of n time. See, it is possible. Binary search is possible on the linked list, but the problem is nothing but to find the mid itself, it will take order of n time. Okay, so again you can perform the binary search on the linked list, but the only thing is it will take the order of n time to find the middle element. Then again you have to compare with the middle element the search key, and based on the comparison either we will search on the left half or we'll search on the right half. Like that we can continue here. Fine. But again if it is less than, our search key is less than the middle element, then it will be on the left half. Again we have to find the middle element. So again it will take order of n times, means whatever the elements we are having in the left half. Okay, so again because of this we can say here, okay, if the finding itself it take here, let's assume here, okay, if I'm writing the recurrence relations for the binary search using the linked list, means here if I say here this is the time complexity of binary search using linked list, then time complexity will be nothing but here T of n by 2, and here see it will be nothing but n only. Why this is n? Because this n is nothing but to find the mid. Previously it takes only constant times. Why? Because finding mid, then comparison, it takes constant times. But here in the case of linked list here, it takes order of n time. Because of this I can say here this implementation of binary search using the linked list, it will take more time. It will not take order of log n time. Okay, fine. So option C is also incorrect. So again see, this is a MSQ question, but still here answer correct option is only 1. Okay, so read the instructions carefully in the examinations. This is not like here if you are having the MSQ question, then the list number must be 2, means 2 options must be correct. No. Okay, 1 options can also be correct in the MSQ questions. Fine, very good. Now fine, so here options A is the correct answer. Fine. Now let's see one more questions here. That is based on the hashing. Question says here, this is again from the data structure. We can say here topic is hashing. Okay, it says here, okay, consider a hash table. Consider a hash table of size 10, equal to 10, okay, with indices, with the hash index given as 0, 1, 2 up to 9. Okay, these are the index of the hash table. Fine, we'll see here. Now with the hash function here and here, with the hash function is given. Hash function is given here, h of x. Our hash function h of x is nothing but 3 of x mod 10, 3x mod 10, 3x mod 10. Understood? Now here it says here, where linear probing is used to handle collision. We already know now this linear is nothing but linear probing technique is nothing but the collision resolution technique. Fine, understood now? This is used to handle the collision. So this linear probing is used. This is used to handle collision. This is used to handle a collision. Fine. Now it says here the hash table is initially empty. Okay, it is given already. The hash table initially empty. The hash table is initially empty. It is initially empty. Fine. And then following keys are inserted. Fine. And this initially the hash table was empty, and following keys are inserted to the empty hash table. Okay, are inserted. So keys are nothing but here the keys are 1, 4, then 5, 6, 14, 10. 5, 6, 14 and 10. These are the keys that is inserted into the initially empty hash table. Fine. And asking the index where keys 14 and 15 okay are stored. Asking this 14 and 15 keys will be stored at which indexes. Fine. Now options here given here. Options A is nothing but here 2 and 5. Option B given with 2 and 6. And option C given here 4 and 6. And option D was given 4 and 5. Understood? So here a hash table is given of size 10. So let's quickly take one hash table of size 10 quickly. Let's assume here this is our hash table of size 10. Okay, so this is first, 2, 3, 4, 5, 6, 7, 8 and 9. So this is our hash table. This is our hash table of size 10. Fine. So here this is our hash table of size 10. Indexes are nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Getting my point now? Understood. Now see this is our hash table, and here the collision CRT technique is used is a linear probing technique. Fine. And we know this linear probings, okay, checks the next slot by incrementing by 1 or 1. Okay. So we will see here. So let's try to insert. Let's take the first key here. The first key is 1. And here we'll pass this key into the hash functions. So h of 1 is nothing but here 3 of x. 3 of x means 3 of 1. 3 of 1 is 3, and mod of 10 nothing but here 3. So again, if I pass the key 1 to the hash functions, it will generate the index. Here it will generate the index 3, and the key 1 will be stored at the third index. Here the key is stored at the third index. Very good. Now the second key is 4 here. Second key is 4. Now if I pass this 4 to the hash function here, so h of 4 means 3 into 4 nothing but it is 12. So 12 mod 10, it will generate 2. Means again, if I pass this 4, it will generate the index 2 for the, okay, to store the element or to store the key 4. Okay, so it will generate the 2. So this key 4 will be stored at the index 2 here. Okay, so here this 4 is stored here. Very good. Now the next is our 5. So insert the key 5. Insert the key 5 where it will be stored. Again, pass the 5 to the hash function here. So what is h of 5? H of 5 nothing but here 3 into 5 is 15. 15 mod of 10, here nothing but here is 5 only. Okay, it is 5 only. Now see, if I pass the key 5 to the hash function, it will generate the index 5. So now the key 5 is stored at the index number 5 here. Understood? It means here the 5 will be stored. Simple, the 5 will be stored here. Done. Means again see, there is no collision, then simply it will store at the index 5 here. Simple. Fine. Now here the fourth is our key. Key is our 6. Where it will be stored? Pass the h of 6. H of 6 is nothing but here 3 into 6 is 18. 18 mod of 10 is nothing but here 8. Now simply this search key 6 stored at the mod or at the index here 8 only. Fine. So here the 8 here means the key 6 will be stored. Very good. Now 2 more keys need to insert here. That is our 14 and 15. And that is the answer only. Fine. So we will try to insert 2 more keys here. Let's insert the next key here. Our 5th key is nothing but is a 14. Now insert. How to insert? Simply pass the 14 to the hash function here. So if I pass this 14 to the hash functions, so what will happen? 14 into 3, it is nothing but here, it is 12. 14 into 3 is 12, 1, 7, 72. So it is nothing but 72. 72 mod of 10. Mod of 10 nothing but here, it is nothing but is 2 only. Now again see, if I go at index 2, again see here, if I go at index 2 here, now see at index 2 already this 4 is stored here. It means there is a collision. So this index leads to collision. Then again what we'll do here, we'll increment by 1. So next index is 3. So at index 3 also we have collision. This index is 3, also I have collision. Fine. Now again go to the index 4 here. Index 4 is empty. Now this key 14 will be stored at the index 4 here. So here 14 is stored at the index 4. So first answer is that 14, the key here, the key 14 will be stored at the index 4. Getting my point? So right answer will be, okay, option A and B simply removed here. Right can be either C or D here. So let's find for the 15 also. So again pass the 16, here the key is 15, here the key is 15 only. Fine. So if I pass this h of 15 again, so pass the 15 to the functions here. So 3 times 15 is about 45. 45 mod of 10 is 5 only. Now see, at 5 already the element 5 is stored here. It means there is a collision at index 5 here. So collision, go and check the next here. Next is 6 here. So 6 is empty. So simply store the 15 at index 6 here, 15 here. So it means the key or value 15 will be stored at the index, okay, at the index 6 here. Index 6. It means the right answer is 4 and 6. So element 14 will be stored at 4 and element 15 will be stored at the 6 here. Fine. So answer is option C. D is also incorrect. This is simple, easy questions. We have already discussed in the, okay, there is one video I have took on the YouTube, mastering in the hashing, all PIQ questions. There we have already took many simple questions based on this concept. Understood? So these were the questions I got from this, okay, for this examination DA. Now, ma'am will take this math questions and she will discuss all the things. Fine? Okay, all the best.
Hello everyone, please confirm whether the audio video is clear or not, guys. Yes, it's clear. So welcome dear students. I'm sure it's perfectly visible. Okay, so
Incoming voice.
okay, so I'm having few questions, dear students, of general aptitude and engineering mathematics. We will discuss those questions. As in the engineering mathematics, we can see, yeah, it's having a good weightage. Okay, we were expecting the weightage should be higher than the last year. So yes, it is same to same. In linear algebra, okay, till now we are not having all the questions, but whatever the questions I am having of the linear algebra, the question are good. Okay, calculus, limit and maximum minima, we were expecting these type of questions okay, earlier, and I think this year also we are having the same to same pattern. And in the probability, we were expecting good questions from the statistics. So I think the same scenario we are having, but although I am not having all the questions with the same or the exact data value, so whatever questions I am having right now, I am going to solve for you, bacho. Okay, so let's start with the very first question, and this is the question of the limit. Let's go with the very first question, and this is from the limit. So the very basic question, and I will say if you attended my lectures, so without solving this type of question, you know that key what can be the answer, because these type of questions earlier has been asked in the gate exam. If you guys are having a good practice on the PYQs, then surely you can solve this question very easily. So this is limit t tends to infinity, root of t square plus t or minus t. These type of questions earlier also we used to solve in very basic question. We know very well what is the key rule in this question. We know very well whenever the limit is there, x tends to infinity or t tends to infinity, we should try to make it 1 by t or 1 by x form. Okay. So here I can see the question is t tends to infinity. I will make it 1 upon t form. How I can make? By going for the rationalization. So you can use here the rationalization. Yes. So you can use here the rationalization simple. So rationalization means with the opposite, multiply with opposite sign. So this will be root of t square plus t divided by multiply and divide with the opposite sign which is available in the numerator. When you will multiply, this is a minus b, a plus b, which will be a square minus b square. When you will apply, this is t square plus t square, root will be gone, minus t square divided by, in the square root we are having t square plus t minus t square plus t square gone. Still I am not applying the limit here because it will give you not the finite result. If it is possible, this is t, you can take t outside from the denominator as well. When I am taking from this square root t square, then only t will come outside. So this will be 1 plus this will be 1 by t, or this will be 1. T and t will be gone. Now as I told you, whenever we are having the question of limit t tends to infinity or x tends to infinity, we should write down the question in 1 by x form. So here we just converted this into the 1 by x form. Here you can see this is in 1 by x form. So here when you will apply the limit 1 by t, 1 upon infinity 0, when you will apply this is 1 plus 1. So result will be 1 upon 1 plus 1, which is 1 by 2, or I don't have options here, or if this is an NAT, so answer is 0.5 or 1 by 2, whatever according to the options we can write down. Guys, you can confirm. Okay. Yes. Yeah. Earlier I was not able to see the video actually. Now I think it is clear. Yes. We are able to see it. Okay. So let's come to the next question. This is the very simple question. The next question we are having from the, this is first question of engineering mathematics. I can go for the second one. What is this? The easy question. Again talking about the simple derivative type of thing. Calculus we will say. So the question is, it's talking about, it's given to us the value of function is e power x minus, what is given to us, please confirm. It is e power x minus e power e power x minus e power minus x by 2, and it's talking about f kth derivative of a, just like na, first derivative f dash x, second derivative f double dash x, third derivative f triple dash x, like this one. This is kth derivative of a. They mention, even if you want you can write down what is this, f k of a is kth derivative, okay, of the function with respect to x, and a is any given point in the given domain. A is any point, okay. Then it is asking f10. This is interesting. F10th derivative at x is equals to 0 is what? F10th derivative at x is equals to 0 is what? Again, as I told you, I don't have option here again, but we can solve. Without option also we can solve, and we can solve this question using any of the approach. So if I am going with the question, what is it is talking about function, na? We want function. So function is e power x minus e power minus x by 2, isn't it? Okay, right. Now if you want to use, because ultimately I can see I need to go for the first order derivative, second order derivative, third order derivative, like this one, 10th order derivative I required. At x is equals to 0, I need to find out the value. This is very simple thing. So what is the interesting thing here? Interesting thing is, if you want you can go with directly, if you want you can write down this function as in, because in the e power x minus e power minus x by 2 is nothing but sine hyperbolic x. So if you want you can use sine hyperbolic, or if you want you can use it directly also in the exponential form. The choice is yours. If I will go with the first order derivative f dash x, this is e power x, differentiation of e power x is e power x minus, this will be minus e power x or minus 2, okay. If I am going with separately, if I will go with the f double dash x, this is to minus minus plus. If I will go with the f double dash x, because minus is already given na, I am looking for first order derivative, so minus minus plus x, or if you want you can write down minus of minus e power x, okay, which is e power x minus minus plus e power minus x by 2. If you will go with the double order derivative, means second time, so this is e power x, again minus of e power x by 2. Similarly, if you will go with the triple order derivative, this is again positive minus minus plus e power minus x by 2 and so on. So one thing we can observe from here, bachon, ki first time now we are having positive first order derivative. Second derivative it is negative. Third order derivative again it is positive, means between e power x and e power minus x. So if you are looking for the 10th derivative, 10th number is the even number na. So this will be same to same, e power x minus e power minus x by 2 even. First approach. If you think, no ma'am, we don't want to go with the exponential, then it's okay beta, the same to same process you can go with this one. Sine hyperbolic x will be cos hyperbolic x. Again double order derivative sine hyperbolic x. So I can see when its second order derivative is sine hyperbolic, so fourth will be also sine hyperbolic, sixth will be sine hyperbolic, eighth will be sine hyperbolic, so 10th will be also sine hyperbolic. Okay, this is your choice, as I told you. Sine hyperbolic again I can put as an e power x minus e power minus x by 2. Now question is asking at some specific point. They are asking the value at some specific point, and that specific point is x is equals to 0 when you will put either here or here. X is equals to 0 when I am putting here. So x is equals to 0, this will be 10th order derivative at x is equals to 0, e power 0 e power minus 0 by 2, which is 1 minus 1 by 2, so result is 0. very easily we can write down the result is 0 here. If you guys tried this question, you can just write down your experience as well. Okay, very easily we can go with this result and we can write down the answer. Alright, so this is the question we are having, and the next question is again interesting question from the linear algebra. So this is if sum of all the elements in each row, what it is mentioned, if sum of all the elements in each row of matrix A, which is a n cross n matrix, is 1. Okay, and they are talking about some specific thing which is B equals to A cube minus 2A square plus A. Okay, what it is given, if sum of all the elements in each row of the matrix A, which is n cross n order, is 1, sum of all the elements, and the matrix B is this one, A cube minus 2A square plus A, then it is asking, then bx is equals to 0 has what? Then it is asking bx is equals to 0, means this is an homogeneous equation. Bx is equals to 0 is having what? Infinite solution, no solution, unique solution, or I think exactly one or two solution, something, exactly one solution, or exactly two solution, whatever it is. Let's solve. It's talking about exactly one solution, two solution, okay, unique solution, or infinitely many. So first of all now, yes, this was the question. You guys can confirm. You guys can confirm as well. Okay, so first of all now we can understand from here one very interesting thing mentioned to us in the question. And what is this thing? Ki sum of all the elements. I am writing here even. What is for the matrix A, whatever matrix you are making. Okay, I can write down, suppose I am making a 2 cross 2 matrix. Although I can take any random example, but still if I am taking a 2 cross 2 matrix 1 0 0 1, so in the 2 cross 2 it is giving you 100% clarity. If you don't want to go with the example, then you can write down directly the property is there. What is the property? Ki sum of all the elements in every matrix or in any matrix, if sum of all the elements, okay, in each row of any given matrix, which is a square matrix, is 1, Hana, then 100% it's one of the eigenvalue is 1, surely. So if you want, you can write down, again I am showing you example. If I am taking sum of each row, sum of each row is 1, here the sum of row is 1, sum of row is 1, huh? So here surely we can see, since this is a triangular matrix, this is an identity matrix directly, I can write down ki one of the eigenvalue I am getting is in 1. So you can write down even ki directly by the property, which is a very common property, ki if sum of all the elements, sum of all elements in each row is 1, then surely one of the eigenvalue is 1. One of the eigenvalue, not all we are saying, one of the eigenvalue will be 100% 1. If you are taking, this is a 2 cross 2 matrix, so we can write down, suppose lambda is an eigenvalue or lambda 1 I can write down as in one of the eigenvalue which is equals to 1. Okay? If I am having one of the eigenvalue, then also I can solve this question. Then using this, what is given to us, we can write down this equation B. So I am writing here, it's B is given to you A cube minus, what is this, 2A square plus A. Okay? We can use the Kelly-Hamilton, we know very well, using the Kelly-Hamilton, we can replace lambda by A or A by lambda, because the Kelly-Hamilton says that every square matrix satisfies its own characteristic equation. So lambda can be replaced by A or A can be replaced by lambda. Okay? So in this one, if I will replace A by lambda, so this is lambda minus 2 lambda square or plus lambda. This will be my matrix B, for which I need to find out the eigenvalue, and I am sure you guys know about this one. If lambda is an eigenvalue of matrix A, so lambda square will be the eigenvalue of A square. In the same manner, lambda cube minus 2 lambda square plus lambda will be the eigenvalue of the matrix B. Okay? So what we can do here, we can write down the eigenvalues of matrix B, putting lambda equals to 1 here. Okay? When I will put lambda equals to 1, this is 1 cube minus 2 1 square or plus 1. You can see this is directly we can write down even 1 cube minus 2 into 1 square plus 1. Okay, 1 plus 1 2, 2 minus 2 is 0. So the result is 0. 0 means one of the eigenvalue. Wait a minute. This is talking about one of the eigenvalue when I am taking for which one? For matrix A, I am taking one of the eigenvalue as an 1, and that eigenvalue I am putting here in this characteristic equation. I am getting one of the eigenvalue of matrix B. So when we are having whatever the order, if B is a n cross n matrix, suppose if B is an n cross n matrix and one of the eigenvalue is 0, then we know very well ki product of eigenvalues is 0. It means determinant is 0. This is important thing. So one of the eigenvalue is 0. It means the product of eigenvalues is 0. So determinant of matrix B is must 100% 0. And it is talking about Bx is equals to 0 beta. This is, it's given to us now, Bx is equals to 0. So Bx is equals to 0, it means it is an homogeneous system of equation. So when the Bx is equals to 0 and B is having determinant as in 0, it means surely ki rank will be less than 2 number of unknowns. Number of unknowns, whatever you are having here, the order is not clear. If it is an n cross n matrix, so rank will be less than 2n. When it is less than 2n, less than 2 number of unknowns, so surely it is having infinitely many solution. Because when this is an homogeneous equation, so no solution ka to sawal hi nahi hota. There is no need of no solution. Okay. So and a unique solution is not possible because here we are having determinant is 0. So you can write down here if directly since the determinant of B is 0, it means rank of the matrix is less than 2 number of unknowns. Rank of matrix is less than 2 number of unknowns. When it is less than 2 number of unknowns, it means it is having infinitely many solution. Surely it will have infinitely many solution. Okay? This is the answer. If options are like this, so you should go with this one which is mentioning infinitely many solution. In that option, if it is mentioned infinitely many solution, that is your answer. Okay? Now, the next question which I am having from the statistics, the next question is from the states as well. This is if x is an continuous random variable. X is an continuous random variable and it's given to you कि probability of x greater than equals to 2 is 1 by 4. ठीक है? As well as, and it's given this one, and what is this? Expected value of x is 1 by lambda. Expected value of x is 1 by lambda, where x is following exponential distribution. Where your x is following exponential distribution, then what we need to do? Then find the value of lambda. Okay. Then find the value of lambda. Let's see how we can go with this question. So first of all, bachcho, we can write down here. The question is talking about what? The question is talking about expected value, है ना? What is given to us? Expected value means weighted average of this one is 1 upon lambda. ठीक है, we will hold it. And we know very well whenever we are having the probability density function for the exponential distribution, we can use it. Okay, the probability density function here, even you can, you can write down here directly the PDF. Whenever we are having a probability, whenever we need to find out the probability density function of an exponential distribution, that is lambda e power minus lambda x, when your x and lambda both are greater than equals to 0, or otherwise the result is always 0. Right? We used to discuss in our classroom the simple thing. So we can write down what here they are talking about. The probability is given to us x greater than equals to 2 is 1 by 4. So let's use it here now. So this will be probability, even I can write down directly, it's greater than, so 2 to infinity greater than equal to infinity fx dx is equals to 1 by 4. What is the value of fx? This is the value of fx. So 2 to infinity lambda e power minus lambda x dx equals to 1 by 4. Lambda we can take outside, this will be e power minus lambda x by minus lambda. Limit will be 2 to infinity, this is 1 by 4, lambda to lambda gone. I need to apply the limit here as well. So this will be e power negative is here already. Okay, so e power minus lambda into infinity or minus e power minus 2 lambda, and that is equals to 1 by 4. We know very well e power minus infinity is nothing but 1 upon e power infinity. Infinities quantity will become 0. Here we can write down minus 0 minus e power minus 2 lambda equals to 1 by 4 minus minus plus e power minus 2 lambda is 4. Okay, write down 1 upon 2 lambda is lambda e power to 4. I need to find out the value of lambda. It means I need to go is ln 4. So ln e base e is 1. This is 2 lambda. MCQ.
hello guys. So we got some questions from the DBMS. Let's discuss the DBMS questions. Okay. Am I audible? Please confirm. Am I audible? Am I audible? Please confirm once. Okay, let's start the DBMS questions here. This question is from the normalization chapter. So the relation is given R A B C D E F G having this functional dependency A goes to B C E F, and then we have E goes to D Z. Then we have BC goes to A. BC goes to A. These are nothing but given the functional dependency sets. Okay, this is FD sets F. Fine. And the options were here. The options were option A was not in BC and F. This R is not in BC and F. Option B given as A and BC are candidate key. A and BC are candidate key. Then option C given here is A, BC and E are candidate key. E are candidate key. And the last D options given here is A is the only candidate key. A is the only candidate key. Fine. Okay. So the question is here, this is our MSQ questions. Fine. So again we know, see, if you want to find whether the relation is in BC and F, means if you want to apply any normal form, the first step is to find the candidate key. Fine. So we will first find the candidate key of this relation, then we will proceed here. Fine. Okay. Now see here, so relation R is given with A, B, C, D, E, F, G, and this FDs are given. We know how to proceed. So first check the RHS of every FD. If any attribute is missing on the RHS, then that attribute will be the part of every candidate key. So here see, A is there, so okay, A is cover, B is cover, C cover, D also there, E also there, F, G, all are there here. So fine. So if all are there on the RHS, then simply you can start with anything. Okay, but you have to start with the logical answer here. See, so we can say we can start with the A, because this A determining maximum attribute. So what we will do here? First we will start here. First we will start finding the closure of A. Okay, if I find the closure of A, then A can determine itself by the trivial, okay, reflexive rules here. Now see, A determining A, then using A I can get the B, C, E, F. Okay, I can get the B, C, E and F. Fine. Now see here, after this I can say here, using E I can get the DG. Okay, I can get the DG, D and G. And last here, using BC I can get the A, but A is already there. So I got all here attributes here, A, B, C, D, E, F, G. All attributes are in the A closure. Now it means I can say here, this A is nothing but our super key. Super key. Why? Because if any attribute closure contains all the attributes of relation, then I can say that attribute is a super key. Now we need to check whether this is a candidate key or not. Again, how to check candidate key? Just check here, is this attribute is a minimal or not. See, because this here, this is a single attribute, so definitely I can say here, because this is a single, so this is a minimal attributes here. Okay, it means this A is nothing but is a minimal super key, and every minimal super key is nothing but is a candidate key also. Okay, it means our first candidate key is A. A is the first candidate key. Now as soon as I get the first candidate key, then mark the A as a prime attribute. Okay, now second step is check all the RHS of here, okay, all the FDs. If this prime attributes is present in any RHS of this FD, then we can simply replace this A by LHS. So here see, I got one FD here, I got one FD having the RHS as a prime attribute A. Then simply I can replace this A, by LHS. So here this is a BC goes to A. Then I can simply replace this A by BC. So I will get here BC. Let's find the BC closure. Definitely the BC closure contains all attributes. Why? Because BC contains BC, and using BC I can get the A. Now as soon as I get the A, because A closure contains all, so definitely BC contains all the attributes here. So A, B, C, it will contain D, E, F and G. Okay? It means now this BC becomes our super key. This BC becomes our super key. How to prove this is a candidate key? Find the proper subset closure. Find the B closure. So here the B closure is only B. Okay, and what is the C closure? C closure is only C. It means I can say here none of the proper subset of BC is a super key. It means here I can say these are not super key. These are not super key. It means BC is the minimal super key, or I can say this BC is a super key with the minimum number of attributes here. So this is a minimum super key. Minimal super key, it means this is also becomes our candidate key. Now we got BC is another candidate key here. So now this B becomes prime attributes and this C becomes prime attributes. Understood? Now see again, check, is there anything here? See, so here D and G are not prime attributes, so leave it here. Now see, in this RHS, C, A goes to B, C, E, F, we can apply the split rule on the RHS. So if you apply the split rule on the RHS, simply I can write here A goes to B, A goes to C, A goes to E, A goes to F, 4, okay, simple functional dependency. And one of the here A goes to B or A goes to C is nothing but is our, okay, having the non-trivial FD having RHS prime attribute. So simply I can replace this A by, I can replace this B by A, then again it will leads to the same starting, okay, candidate key here. So again it means here we are having only two candidate key for the relations, given relations here. So one is A and one is BC. One is A and one is BC. So one thing is clear, for the relations are having only two candidate key, one is A and one is BC, so B is the right answer. And again it says here A, BC and E are the candidate key. No, this E is not candidate key. It means option C is incorrect. Option C is incorrect. And option D says also, see, option D says also here A is the only candidate key. No, A along with A I have also BC is candidate key. It means option D is also incorrect. Now left out is A options. Now see A, also check here A. R is not in BCNF. How to check BCNF? Again see here. BCNF property is, it says here a relation R is in BCNF if every non-trivial functional dependency X goes to Y with X must be super key. X must be super key. Means every non-trivial FD here X goes to Y. This X must be, if this X is super key, then only this FD will be allowed in the BCNF, and all such non-trivial FD for relations, if all are having this property, then I can say R is in BCNF. Now check here how many FD we are having here. So 3 functional dependency having. Okay, functional dependency. Now see, for the first functional dependency here, let's see here. Let's see, the first functional dependency is A goes to BCEF. A goes to BCEF, where this A is nothing but is a candidate key, and we know every candidate key is a super key also. So this is a super key also. It means I can say this FD is allowed in the BCNF. Then second is our E goes to DZ. E goes to DZ, where I can say this E is not super key. If this is not super key, then this will be not allowed in the BCNF. Means because of this I can say R is not in BCNF. Yes, the condition is true. It means option A is also right here. Why? Because it says here R is not in BCNF. Yes, the R is not. Why? Because this E goes to DZ is violating the condition of BCNF. Understood? So it means here the R is not in BCNF, means option A and B are the correct options. Understood? So this is the given, okay, question on the DBMS. Let's take one more questions from the DBMS. Now one easy questions comes from the, okay, keys part. Keys, this is again from the, I can say the basic of DBMS. Basics of the DBMS that we used to discuss in the classroom. What is foreign key, what is candidate key, everything. So see here, one relations definition is given here. Okay, it says here one person. Okay, a relation is given with Aadhaar as a one of the attribute, and the domain of this is a character type having size. Okay, the domain is the character char, and here the size is given as a 12, and this Aadhaar attribute is declared as a primary key. Okay, fine. Now see, one more attribute in the person relation is having name, and this is a varchar, variable characters type, and here this is nothing but is of, okay, size is here 32, and this is, okay, this is a normal attribute, name is the normal attribute, fine. So these two attributes are given for the, okay, person relations here, fine, done. One more relation is given is customer, and here the first is nothing but our name attribute. This is also a varchar, and here the size is given as a 32, and this is a normal attribute, fine, name is normal attribute, fine. One more is nothing but our email, okay. Then we have this varchar, and here the attribute size is nothing but is 32, and now see, now this email is declared as a primary key. This is a primary key, okay, primary key. This email is a primary key, we will discuss, okay. Now here see, next is one more is our phone is a character type, okay, it should be integer, but let's take is a size is 10, and this is a normal attribute here, fine. Now here we are having this Aadhaar, one more attribute here is Aadhaar, okay, this is a character, size is 12, and it says here this Aadhaar is a foreign key, references to okay, references to the person table, of Aadhaar attribute, fine. These are the, okay, given here structure. Now here options are given for this problem, options are given here. A options are given, and asking here, okay, which of the following is or are correct? Which of the following is are correct? Fine. Now option A is given as here, Aadhaar is a candidate key of person. Aadhaar is candidate key of person. We'll see. Then option B is given as phone can be, okay, phone can be null in customer, phone attribute. Phone can be null in customer relation. Fine. Now C given is Aadhaar can be null in person. Aadhaar can be null in person. Okay. Now here one more last option is given here is Aadhaar is a candidate key in person relations. Option D is given here. Aadhaar is candidate key of person relation, is person relation. Okay, fine. So these are the given options. Okay. So what we will do yet quickly we will take the construction here, the given relations. Let take the two relations here. One is our relations person having two attribute. One is our Aadhaar and one is our name. Fine. And one more relations. Let's take here one more relations. Okay. This relation is nothing but is a customer relations having 1, 2, 3, 4 attributes. So this is the first attribute, second, and let's take the third, and this is the fourth. Fine. Now let's see here. See here. So this given relation is nothing but is a person relation. Persons having two attribute. One is the Aadhaar here, Aadhaar, and here this is our name. Fine. Now here this is our customer relations having attribute name, then email, email, and we are having the phone, and last is our Aadhaar. Now see, now as per the given constraint, see here, now Aadhaar here, this Aadhaar is nothing but is a primary key of the person relation. Similarly here, this email is a primary key of the customer relation. And one more thing here is this Aadhaar is a foreign key referencing to this Aadhaar of the person relation. See, again we know here, if any attribute is a foreign key, then that attribute will refer to the primary key or alternative key of the other table. Getting my point? So this is the reference table, this is the referencing table. We have already discussed. Now see here. Now one more here. We know already in the class we have discussed here, this primary key, okay, or we can say alternative key. These are nothing but is a part of candidate key also. Okay, let's assume here, if I say here, this is our candidate key. Candidate key is attribute A1, A2, okay, then A3, then A4. Means any relation is having four attributes. Means let's take here in other, maybe you're confused here. See, let's take here, there is relations R, and the relations R is having candidate key as a A1 attribute, A2, A3 and A4. Fine. Now see, again we have discussed in the classroom that one of the candidate key of the relation is assigned as a primary key, and remaining all will be the alternative key. Okay, and one more thing, see here, this primary key attribute is not allowed null, and here alternative key can have the null values, but here primary key cannot allowed null. Means it should be not null, along with not null this must be unique. Why? Because already this is a candidate key, means we know candidate key must be having the attribute set that must distinguish the record uniquely. So definitely this A1 unique, this is having the unique property. Along with this unique, one more thing is applied condition here, if anything is primary key, then that should not allow the null. Okay, the alternative key can have the null value. Fine, done. Okay, now see here, it means here I can say here, whatever the Aadhaar field we are having, here, see, so if Aadhaar key is primary key, then I can say this is nothing but is a candidate key, because primary key is nothing but one of the candidate key. Similarly, if this email is a primary key, then email must be the candidate key here. So one of the candidate key assigned is our primary key here. It means here this Aadhaar and the email of the customer is nothing but is a candidate key only. Understood? So again the first option says here Aadhaar is a candidate key of person. Yes. Why? Because primary key is nothing but one of the candidate key. It means Aadhaar is a candidate key. So option A is correct. Now see, it says here Aadhaar can be null in the person. Aadhaar can be null in the person. No. Why? Because if the Aadhaar is a primary key, then this field should not null. This field should not be null here. Okay, not null. It should not have null. It means here Aadhaar can be null in the person. No, this statement is false. Means this C option is incorrect. Understood? Clear now? Now see again see here. So it says here phone can be null in the customer. Phone can be null in. If you observe here, this phone attribute is not candidate key. So again I can say this phone attributes can have the null. Means maybe one of the some of the customer, let's assume here, if I say here there is a customer name is Amit and email is E1. Maybe that customer Amit is not having phone, so in that case I will simply put the null in this row here, and maybe having Aadhaar card A1. Getting my point? Understood? It means this phone can have the null. If that customer is not having any phone number, then simply I can put the null here. Understood? Because there is no constraints defined on the phone number. So here this phone can be null in the customer. Yes, this is absolutely true. So option B is correct. Okay, now option D says here Aadhaar is a candidate key of person relation. Aadhaar is a candidate key of the this is already defined now. Okay, not candidate key of the person. Let me check here quickly. Aadhaar is a candidate key in the customer. Okay, in customer relation. Customer means last option is Aadhaar is a candidate key in the customer relation. So now it's asking here that Aadhaar is a candidate key. No. Why it's no? Because see, again the foreign attributes whatever we are assigning here, this may be the key attributes or may not be key attributes. There is no constraint on the foreign key. Okay, getting my point now? So if it is a foreign key, then it may be the key attribute or may not be the key attribute. Okay, now it says here, can I say Aadhaar is a candidate key in the customer? Let's check here, So what is candidate key? If any attribute, I say if any attribute is a candidate key, it means that attribute must distinguish the record uniquely. Getting my point? Let's take one scenario when I can say Amit is one of the customer. Getting my point? Understood? Now Amit employee having this email is having E1, phone is null only, then Aadhaar is A1 only. Okay. Now let's assume Amit again wants to have one more records in the customer table with the different email. Why? Because if the email is a primary key, then definitely this field must be unique. I cannot put here E1. Okay, getting my point now? So it means here this email must be with the one more email here. So Amit is having one more email, so here it's E2 only. So Amit E1, Amit E2 both are having distinct records here with maybe having phone number, this time phone number maybe I can say, or let's keep it null only, no problem. Okay, now Amit is already having Aadhaar card A1. So definitely whenever I am referring this Amit again, then Aadhaar card will be A1 only. And because this Aadhaar card is nothing but is referring to the person table, then here one Amit will be there, one Amit entry, and Aadhaar card is A1 only. Getting my point? Understood now? And this field must be unique. Means here again we know if anything is foreign key, then I can say here this attribute field that customer.Aadhaar must be subset of, this field value must be subset of the person.Aadhaar. Here must be person.Aadhaar. This is the property of the foreign key. Means this Aadhaar card field value must be the subset of this person.Aadhaar field here. So if Amit is having A1, then that definitely whenever I am referring Amit in this customer table, then by default this Aadhaar card will be A1 only. Now see, I have two records with the Amit, and again as per the constraint, this two records satisfying the constraint here. See here, this email is having two distinct email here. Understood? So it is satisfying the primary key constraint here. Also in this person table, I have Amit with the Aadhaar card A1. This also satisfies the constraint only. Now see, because of these two repetitions, I cannot say, so now see if I say this Aadhaar is nothing but is a candidate key of customer, then using Aadhaar I cannot distinguish these two record. Why? Because these two record having same Aadhaar A1 and A1 only. Understood? So based on that I can say here this Aadhaar of this customer cannot be the candidate key. So option D is incorrect. Understood? It means here the right option is our A and B. A and B is our right answer. A comma B is the right answer. Fine? Done. Very good. This is the easy questions from the basics of the DBMS. Fine. Now we'll discuss one more questions. Let's see here. Okay. Fine. Now see one more questions given SQL question here. Okay. Easy question. This is SQL question. Now see here. In this questions here, basically in these questions, we are given with a table loan. We are given with one table loan having three attributes. Fine. Here, one of the attribute is our loan number. Okay, this is our loan number, and this is our branch name. And here this is our amount, and this relation is nothing but our loan relation, loan table. Having some records are given, instances given. Let's see here. The first record is the loan number is 11 and the branch name is nothing but Banjara Hills. And here the amount is our 90K. Understood? Now see here, next is, this is our first record. Now, next is our 14, loan number is 14 and this branch number is Kondapur and the amount is 50K. Done. One more record is given with the loan number as a 15 and here it is a SR Nagar. Okay, and the amount is 40K. Now here 22 is one more loan number having same SR Nagar as a branch name. from the same branch, and amount this time is 25k, 25,000. Fine. Now one more record is given with 23 here, 23, and here this is a Balanagar, and here this time this is a 80k as a loan amount, 80k as a loan amount. Now see here, now here one more 25 is our loan number, and here this is a Kondapur is a branch name, and loan amount is our 70k. Fine. And one more last one is given, this is a 19, and this is our SR Nagar, and loan amount is 65k. So this is the given relations for the SQL. We'll refer these relations here. Fine. But let's first write the given SQL here. So SQL was given here, SQL. Fine. The SQL was given here. See, select L1 dot loan number, select L1 dot loan number from the relation loan L1. Okay. Now it says here where condition says here that L1 dot amount must be greater than here one inner query is written. What is inner query here? It says here select maximum. Max is the aggregate function that is defined over the L2 dot amount. Fine. And here it says here from loan, same loan table here, one more loan table as a L2 here, where condition is where L2 dot branch here, L2 dot branch name must be equal to SR Nagar. This is our given SQL. Understood? Now question says here the number of rows returned by the given SQL. Understood? So see here now. See the first thing tell me here whether the given here this given SQL is okay, is with correlations or without correlations. Okay, the given SQL is nothing but, if you check properly here, see the relations L2 here. Okay, the inner query, this inner query is not using any attribute of the outer relations. The outer relations, okay, outer query relations is L1. So we are not referring any attribute from the L1 in the inner query. It means this is nothing but SQL without correlation. Inner query is independent of the outer query. Understood? So this given SQL is a without correlation. It means here, see here, this inner query is independent of the outer query. Understood? Fine. Now see, very easy. See here. So if the SQL is, so after identifying if the SQL is here without correlation, then simple process is here, if the inner query is independent of the outer query, then the approach will be bottom to top. Bottom to top means first we will execute the inner query, will find the result of inner query, and that result will be used as a input to the outer query. So first we will find the result of the inner query. So what is result here? See, so what this inner query is doing here? See here, basically here, so it says here from loan L2 here, means take one copy of the loan table as a L2. Now from this table, okay, apply. See here, again see here, we know here the execution always start from the from clause. So first is from loan L2, take one copy of this loan table as a L2. Then after that apply the condition where L2 dot branch name is equal to SR Nagar here. It means just keep all the records having the branch name as SR Nagar. So how many having the branch name as SR Nagar here? See 1, 2 and 3. So this 3 records is having the branch number as SR Nagar here, this 3. Getting my point? Understood? So these three are nothing but are the branch number with the branch number as SR Nagar. Now after selecting this branch number, it says here, now from that select the L2 dot amount, okay, or we can say from the amount attribute select the maximum value. Select the maximum value. It means here this inner query will result, it will result one attribute name as a maximum L2 dot amount, okay, and the value will be maximum among these three. So what is maximum here? If you check here, maximum is 65k. Maximum is 65k. This maximum is 65k. So here this 40, 25 and this 65k. So maximum will be 65k. Maximum will be 65k. Getting my point? Very good. So this is the result here. This is the result of inner query. This is the result of inner query. Result of inner query. Understood? Now see, now this result that is having maximum amount as a 65k, this will be used as a input to the outer query. Now what is outer query? It says here, okay, start from the from clause. So take one copy as a loan as a L1. So okay, take the one copy here. Let's assume we took one copy here as a L1. Very good. So take one copy as a L1. So assume here this is our L1 copy. Now from this L1 copy, apply the where condition. Now see what this where condition? This where condition is tested on each record. So now here we'll apply the where condition on this each record, and if the record satisfy the where condition, then we'll select that record. Simple. Okay. Now take the first record. So from the first record, it says here where L1 dot amount must be. See here where L1 dot amount here, this amount must be greater than, this amount must be greater than this result here. Okay, now take the first record. First record says here L1 Banjara Hills amount is 95k. So for the first record, see here for the first record amount is 90k. Now 90k is greater than 65k. Yes, means first record getting selected. Why? Because the condition is true. If where condition is true, then this record will be selected here. Very good. Now again same here. Same, take the second record. Second record is 14. This 14. Kondapur and 50k. Now from the second record, see from the second record, what is loan amount? Loan amount is 50k here. Now is it greater than 65k? No, means this okay, this record, second record will be rejected. Understood? Clear now? Now see here, now see again third record having this is 40k. Now tell me here, if this 40k is greater than 65k, no means the third record will be rejected. This will be rejected here. Similarly, the fourth record having loan amount as a 25k. Now this 25k, is it greater than 65k? No, means this will also get rejected here. This fourth record also rejected here. Now similarly here, the fifth record. Now fifth record is nothing but 80k. Okay, this is our 80k. 80k greater than 65. Tell me, is it true or false? It's true here. 80k is greater than 65k. It means this fifth record getting selected here. It means this is selected here. Very good. Now here last one is here. See 26th record is nothing but 25 Kondapur and the amount is our 70k. Here this is a 70k. 70k, tell me here, is this 70k, is this greater than 65k? Yes, means this sixth record also getting selected here. This record also selected here. Fine. And the last record, our seventh record is nothing but having the amount as a 65k. 65k, tell me here, is this 65k, is this greater than 65k? No, see here, see, 65k is equal to 65k, but this is not greater than. Here see, the condition here, the condition is strictly greater than. This should be, the amount must be strictly greater than 65k. So here, because this is not strictly greater than, it means this getting rejected here. It means the last record will be rejected. Understood? Now see, now says here, now see here, now it says here, now from after this where condition, see here, this where condition tested on each record and based on the condition satisfied here, see this three record getting selected. Now from the selected record, it says here select L1 dot loan number. Okay, now from all this, okay, selected record, it will just fetch the loan number here. Fine. So it means the output will be nothing but here. Okay, it will contain, it will have one table with the attribute name as same as a attribute name will be same as the L1 dot loan number here L1 dot loan number, and here how many loan number we are having here? See the loan numbers first, from this first selected record the loan number is 11, so here it will be 11. Now here from this selected record the loan number is 23, so it will be 23. Now from this loan number 25, so it will be 25. So I can say here the number of rows returned by the SQL, this SQL is nothing but here 3 rows or 3 tuples, 3 records. Okay, it will be records or tuples, anything you can say here. Fine. It means the answer is 3. Answer is 3 only. If this is an NIT question, then answer will be 3. Understood? Very good. This is the easy questions we have already discussed, okay, in the classroom. Fine. Now see, one more interesting thing is here. So based on the same table here, one more SQL were given here. So we'll take the same here. See here, we will take the same. Let's just make one copy of this relation. Okay, let's take one more copy here. Now, okay, we'll solve this question. See, let me just write the table and the given SQL here. Fine. Now see here, one more question is given based on the same data here. Let me just write quickly. Okay, the question, one more table is given here. One more table is given here. See, one more table is given here. One more table is given, and the table name is the borrower. Okay, having 2 attributes, one is customer name and the loan number. Only 2 attributes, one is customer name and the loan number. This is our borrower table. Okay, this is our borrower table. Fine. Having this is our customer name, here is a customer name and here is a loan number. Fine, very good. Now the first customer name is Anand. Okay, first customer name is Anand and the loan number is 11. Now here next is Karthik and the loan number is again 11. Now one more having record with the Karthik as a customer name and the loan number is our 14. Very good. Now one more is Ankita and here the loan number is 15. Now next is Gopal and the loan number is 19. Next is again Karthik and loan number is 22. One more Karthik, one more record with the customer name Karthik and this is our 23. Now I can see one more with this is our Sunil with the 23 as a loan number. Then here one record with one more customer name Sunil and the loan number is 25. Understood? So these are nothing but the given borrower table having the 2 attribute and details are this. Fine. Now let's discuss here. Let me first write the given. Okay, here the given expression. The expressions was given here. See, it was given expression. This is from the relational algebra. Okay, this is not from the SQL. This is from the array relational algebra. Fine. Here the array expressions here. The array expression is given. Array expressions here. Okay, it is given here. First take the loan and the borrower. Okay, take the natural join between the loan table and the natural join between the loan table and the borrower. Fine. Now after this here, now from that here, project the, okay, from that project the customer name, and it says here also project the branch name, okay, branch name. Now see, so take the natural join between the loan and the borrower, and from the result of this natural join, just project the customer name and the branch name. Now after this, it says here, perform the division. Perform the division. This division, you can write this division also, or we know if you perform the division here, so both are same only. If you write here this operator, or both are same only. So perform the division, and here the denominator is given as a loan. So from the loan table, project the branch name. Project the branch name. Project the branch name. Fine. Very good. So this is the given RA expression. This is the given RA expression. Getting my point? And we need to find, okay, we need to find the result of this. Very good. Okay. Now tell me here. See here. Now see. Again. First thing we know here. If this is a division means see here. Division means again we know here. If it is a division, then again see division operators. We have already know the notations here. We need to retrieve the customer name. Means here retrieve the customer name. Retrieve this customer name. Okay, customer name. Okay. If the customer respective branch number, see here, retrieve the customer name such that the respective branch number is matching with every branch number of the denominator. If it is matching with every branch number of the denominator. Getting my point? Now first thing is here, see here, first find the result of this denominator. Now from this loan table, if I project the branch name, then what is the result of this here? See, what will the result here? So quickly let's take here, let's generate the denominator result here. So see, denominator result here, see here. So here this result is nothing but having the attribute name as a branch name, and project the branch name. Now one thing, see here. See, this is nothing but RA expressions, and we know RA expressions by default generate the distinct records here. So if we are having this repetition SR Nagar, then it will only take once. Okay, it will always take the unique here. Fine. So again, the first branch name is Banjara Hills. First branch name is Banjara Hills. Banjara Hills. Now, the second branch name is Kondapur. Then the third branch is our SR Nagar. And after this we have the Balanagar also. Okay, and last is Kondapur is already there, so skip this. SR Nagar is already there, so skip it. Means here the result of the denominator is nothing but having 4 records with the 4 branch name: Banjara Hills, Kondapur, SR Nagar and the Balanagar. Now see, it says here, first perform the, okay, now the question is here, we need to generate the result table of the, okay, numerator here. Numerator is having this, first perform the natural join between the loan and the borrower. And we know how to perform the natural join. We know that natural join perform between the, because this is a natural join, this is not conditional join. Natural join means the condition is, by default condition is equality between the common attribute. So we'll take the common attribute. Common attribute is here, see, between loan and the borrower. The common attribute is our loan number. This is our loan number. So again, if I want to perform, then basically it will join the records of loan with the records of borrower if the loan number is equal. Getting my point now? It will join the records of loan with the records of borrower if the loan number is equal. So let's generate. I am generating for you. See, we can do it quickly here. Again, we can say here, see, how many records? See, the first record loan number is 11. It is matching with this 2 record. So first record will be paired with these 2 records. Similarly 14, it will pair with the third record. Here is 15, it will pair with the Ankita here. Then again 22, it will pair with here Karthik. Then again 22 pair, then 23 again this will be paired with this Karthik. 23 it will again also pair with the Sunil. 25 it will be pair with this Sunil. Anything else? 19 is here, 19 here. Now this 19 will be pair with the Gopal. Anything else? No. Done. It means here see how many records will be there in the result of this natural join. Result will be 1, 2, 3, 4, 5, 6, 7, 8, 9 will be there. So I am writing this 9 records. Okay, fine. Now next question is what will be the schema? What will be the schema of this join? So again we know schema, whenever we perform the join between the table, then it will merge. Okay, we know here. Okay, discuss this here. Let's discuss this here. Fine. See, again we know here if you perform the natural join between the loan and the borrower, then it will join this two and it will merge the common attribute. So let's assume here this first is our loan. So keep all the attributes of here. Okay, loan here. So first attribute will be loan here. So one attribute is for the loan number, and here one for the branch name, and one for the amount. Getting my point? One for the amount, and from this borrower it will having the customer name. Why? Because this loan number is already merged with the loan number of the loan table. Fine. Now see how many attributes here. The first is our loan number. Then here it is a branch name. And now we have the amount. Now last one is the customer name. Okay, now let's quickly find all the 9 record here. So first record it will be merged with the loan number 11. Loan number is our 11. And the branch name, what is the branch name? Branch name is Banjara Hills. I am writing the BH, Banjara Hills. Fine. And amount is 90k. And customer name is Anand. Fine. Now here one more record. See here, merge this record again. The loan number is 11, branch name is Banjara Hills. Okay, amount is here, amount is again this is a 90k, and this time the customer name is Karthik. Fine. Again see, now again this 2 is merged with the first 2 record. Done. Then here 14, this is a loan number is 14, branch is Kondapur. I am writing KP, Kondapur, and here the amount is 50k. And it will be merged with the Karthik here. So here name is again Karthik. It is a Karthik only. Fine. Very good. Now again see this 15. SR Nagar is 15. 15 here. Then it is a S. I am writing SR Nagar SN. I am writing the SN SR Nagar here. 15. The amount is 40k. Okay. So this will be merged with the Ankita. Ankita, customer name is Ankita. Okay. Similarly here see one more is 22 and SN is our branch name SR Nagar, and it will be merged with the Karthik 22. It will be merged with the Karthik. What is this amount? Is a 25k. And name is here Karthik. Customer name is Karthik. Very good. Now 22 is done. Then is 23. 23 is nothing but this is loan number, and this is a Balanagar. I am writing here is a BN. Balanagar is a BN, and amount is a 80k. Here amount is 80k, and it will be merged with the Karthik. Okay, it will be merged with the Karthik. Very good. Now again one more thing here. 23 Balanagar, amount is our 80k, and this time the customer is, see here it will merge with the Sunil because the loan number matching with same loan number 23 here. So again it will merge with the Sunil. So it's a Sunil. Now again see this is done. Then 25 here. Then loan number is 25. This 25. Then it is a Kondapur. This is a KP. Kondapur KP, amount is 70k, and it will be merged with the Sunil. The name is here, it's a Sunil here, Sunil. Very good. Now the last one is 19. Loan number is 19. It is a SR Nagar, is our SN. Amount is a 65k, and it is matching with the Gopal. So name of customer is Gopal. So these are nothing but the record of this join. How many records here? 1, 2, 3, 4, 5, 6, 7, 8, 9 records. Now see here. Now if you perform the division, so division says here, okay, retrieve the customer ID, Okay, retrieve the customer name if the for that customer respective branch is matching with all the branch of the denominator here. It means is there any customer that took the loan from or that is associated with all the branch of denominator. So can I say here, so see Anand is present one time and the branch name is BS. So remove the Anand because it is only matching with the only one is Banjara Hills here. Again, same is Ankita. Ankita only associated with the SN, SR Nagar, so remove that here. Again, Sunil's associated with two here. One is our Balanagar and one is our KP, Kondapur. So it is not matching with or it is not associated with the Kondapur or Banjara Hills, so remove that 2 here. Last is Gopal. Gopal is only associated with the, okay, I can say here, SN. SN means SR Nagar here, so remove that also here. Now left is Karthik. See here, Karthik is, okay, associated with the Banjara Hill also. Karthik associated with the Kondapur also. Karthik associated with the SR Nagar also. And Karthik also associated with the here Balanagar also. Means Karthik is the customer that is associated with all the branches of the denominator. It means remove the Karthik here. So result will be nothing but Karthik. Okay, or we can say here result will be one table, okay, one table where the attribute name will be here customer name, and here one customer Karthik will be there as a result. Karthik, understood? So it means answer will be, if it is an NIT question, answer will be 1. Answer will be 1. Only one record will be there in the result of this SQL. Okay, not SQL, this is the R expression. Fine? Done. Very good. Okay, so many more questions are there. We'll discuss after this response sheet. As soon as the response sheet will generate, we'll discuss all the questions at once only. Fine? Okay. All the best. Bye bye. Take care.
Hello, my dear students. So I hope this like analysis definitely help you a lot, because a lot of questions we discussed from especially programming and data structure algorithms, and good number of questions from DBMS also, and some of the questions, whatever memory based questions we got from engineering mathematics, that also we have done. Okay, so now so some more information we would like to share it, like just a minute. So I am strongly recommending all of you try to join this Telegram group. So you can get the notification, all the notification, job notifications or any admission notification, as well as some free content PDF form. So that will be getting, even this whatever so far discussed, this entire PDF also we are sharing in this Telegram group. So when it comes coming into the IMS we are offering the courses for the 2026 and 27. Like online classes we have, as well as Malaysia, like in Bangalore we have 2 offline centers are there here. So when it comes to online, you can see like online and offline more than 18 hours classes we are giving, and having a exercise book which contains more than 4,000 questions which are must sufficient to like for the preparation. So we have like 33 years of the GATE previous year booklet which contains most of the GATE questions and their solutions, even the video solutions also kept. So now we are offering one unique feature is that 12 personalized mentorship one-to-one session with faculties that you can have. So we have more than 130 tests when it comes to chapter test, subject and multi-subject, and mock test, 12 mock tests will be there. So these are the main features we are providing. So and also I am recommending everybody try to join at least this zero free program in which the 50 hours of the free content is provided, 50 hours of the free content, followed by one personalized guiding sessions will be there. So 3 free gate chapter and a subject test also will be giving you, and definitely 2024 especially CAC and this analysis part of the solutions. What are the questions, memory based questions are there, we are going to give it. I am strongly recommending to join this zero free program, see the content, then you can plan for a 26 program. And one important update, all my dear students, so national scholarship test we are going to conduct, the test at 23rd February this. So you will be getting up to 40% discount. So you can also see that if you scored, so between 90 to 100, 40% discount, 75 to 89, 30%. Based on your score, you will be getting up to 40% discount on any course. It can be online or offline or even hybrid model also we have. Few, like we have a branches in Bangalore, 2 centers, offline centers, in Vijayawada also we have. So most of the branches we are running the, what you can say, one is a full regular course as well as a hybrid model, some subjects in online, some subjects in offline. So that will be there. So you can definitely try to enroll for this test and get up to 40% discount. Okay. So anybody having any queries, ma? Anyone? Abdul? Anyone have any queries? So that we can help you to. Okay. So thank you so much all, and one important thing I would like to add here. So after this results of the gate 25, like 17th March, after that we are going to conduct the series called post gate guidance, in which we'll be discussing the major top IITs and top NITs, their course offering, like what are the courses they are going to offer, what was the cutoff of the previous years, the various things we are going to be discussed. So all I'm recommending you, subscribe this YouTube channel, so so that you will be getting the notification for those sessions. Those sessions are going to be helpful for you. So all the best, all of you. Thank you so much all.